As of now, we started our journey from the source code management. Then we move to the build automation. Then we move to the code coverage. Then we move to the understanding the importance of Nexus. Then we started continuous integration, and we started continuous delivery using Jenkins with Groovy pipelines, as well as we integrated applications and we deployed application into the Tomcat. As I discussed, Jenkins is a continuous process. We'll try to cover in the Docker level and the Kubernetes level as well as Ansible level. So there again, we'll discuss about some topics in the Jenkins. Either it's a pushing the artifacts, the Nexus, or some kind of multi-configuration. As of now, we created 5 different jobs in the Jenkins. One is freestyle job, Maven projects, pipeline, multi-job, master slave, and multi-branch pipeline. Master slave is not a job. Multi-job and multi-branch pipeline we discussed. There is a multi-configuration environment is there in the Jenkins. Definitely, we'll try to explain the different environments inside the Docker so that I can able to explore more clearly to you how to configure the different environments. How can I do our own deployment into the Docker? So let us move forward. Let us introduce a new tool called as a Docker. Hope all of you heard about this word, Docker. Right now, industry buzzword, if you're looking at the last 7 years onwards, Docker and Kubernetes. So before starts the Docker architecture or Docker environment, first you need to understand what happens before Docker. So what kind of development environment, testing environment, and production environment. How this Docker changes the world of virtualization, where virtualization step back and it pushed back the pushes the Docker to the upfront in order to develop and deploy application in the container platform. You no need to worry about the containers as of now. We'll discuss very clearly about what is container platform. Before starts the Docker, very simple key point here is when you are in agile process, when you take the dynamic development environment in our IT, especially nowadays, not only nowadays, if you are in the business world, our software development really need to be agile, isn't it? The more important. So before talking to the Docker, our software need to be agile. Keep in mind. So if it is agile, obviously we got more shoulder responsibility to react very quickly to change. This is the one fundamental things. That's it. The entire industries revolve around these two terms only, whether you developer or tester or anywhere. So software need to be agile and you need to react quickly to the change. Definitely. That's why we invite the agile model. But when you drive the project or when you drive the projects in the company with the technology, there are some influencing factors need to be considered at the time of development, testing, deployment to the clients. Those are all painful things to the development team and administration team and networking team in order to propagate our applications from one environment to another environment. While developing, while running, while testing, while shipping all these applications from one environment to another environment before handover to the production or at the time of handovering the application to the production, you may face, not may, we are all facing some kind of problems. Especially now when I talk about, when we talk about agile process, we are all using some kind of agility techniques like in a Scrum methodologies. And we are developing some kind of story points. And we are involving some daily stand-up calls every day, 15 minutes. What we done yesterday, what is today, what is the gap between the features. Of course, we are running with very fast and our focus on reacting the change. We need to reacting. We are reacting the change and we need to develop and release the solutions very fastly to the client. Absolutely, it's required. But what about preparing the software environment? Remember this key point. So what about preparing the software? What preparing the software? Yes, absolutely. If I take my developer side or tester side or who wants to develop, who wants to run their applications, whatever our applications, application is having dependencies, operating systems, databases, code, libraries, scripts, configuration files, libraries, other things. You need to prepare such kind of software to the each and every individual team in the project. And you must focus on the shipment of the software as well as those shipment must also be focused on the deployment. These are the three areas we struggle a lot in the traditional development, even who are effectively following the agile process in the software organizations. Every time I focus on my developing the change, yes, I'm reacting my client change. I'm ready to give the code to whatever they request in a dynamic environment or in a dynamic level. But at the same time, developing software is not only a finished job. You need to do a lot of things. Once our developer is build the code, you need to propagate that code. You need to ship the code to the multi-environments. You have to test it. We have to approve it. Then we have to hand over the ready-made code to the production. It means while developing, shipping, running application across the different environments, there are some problems we faced. That's what we need to discuss. Before Docker, what is the development behavior? And after Docker, or at the time of arrival of Docker, what is the Docker behavior? Once you understand that, now we'll talk about what is a Docker Docker engine, Docker machine, Docker client, Docker registry, Docker hub, Docker daemon, Docker layer, Docker image, Docker container, Docker index, Docker compose, Docker swarm. So Docker secure, these are all basically the topics in the Docker. So when you looking at the traditional development lifecycle, not traditional development environment, as you know very well, if you take our development pipeline, what development pipeline typically contains? Obviously, they must develop the applications. And for developing application, they need a different kinds of softwares. They need to download the latest kinds of softwares. And they need virtual machines. And they need some configuration management tools. They need different kinds of packages. And all these things, if you observe very carefully, I need a VMs. Suppose virtual machine. Who will configure the VMs? Some X team, configuration team. Okay. On top of the VMs, I want to configure my servers. Who will? Server team. Great. I want to do some kind of networking issues. Maybe a networking team will come into the picture. And I want to develop a software code by using this environment. My dev team is entered into the picture. What it means in a single application, when you talk about the infrastructure, I'm talking about the provisioning. What are the fundamental provisioning required to develop an application? So I need a software house. There I need a proper network. There I have proper configurations in terms of machines and servers and softwares. Those things will be configured properly. Then I sit on the top of the machine, then I can start my development. It means you are working under dependent fashion. Dependent fashion in the sense, as a developer side, developer is keep on developing the code, may fail to run this software on different environments because maybe there is a changes in the configuration, there is a version incompatibility of the operating systems or other softwares, or some kind of hardware failures, maybe some kind of libraries missing. Then he don't want, he only blindly say, the code is okay, but application is not running properly. Then I want to do some diagnosis, he's saying like that. What it does mean here, when you're looking at my explanation, all the things are managed by the different people. Got my point? So different people in the sense what? Configuration engineers, networking engineers, server engineers, developers. They are grouped together in the network environment, they are working. While working, some kind of isolation is entered into the picture. So obviously, there is a more problematic thing is there. Problematic in the sense, problem is, my tester says that code is running on the developer machines only, but unfortunately, code is not running on the testing machine. So run on my machine is the very problematic term nowadays. You must maintain a uniform development platform that need to be developed, run, ship applications on anywhere across any environment. It may be on premises, it may be in a cloud. So what I'm trying to say, if I say development environment or testing environment, for example, looking at here, Suppose if I say development, then testing, then if you take like in a production. So here, this is my dev machine, this is my QA, this is my production. So as said, all these environments, dev environment, QA environment, production environment, need to be have different. So my development environment, if I consider, suppose here they configure their own environments. Here also they configure their own environments, and here also they configure the production environment. Just for example, on top of these three machines, for example, they configure a vagrant here. They configure their own software here and there. Suppose when I'm looking at here, according to my development machine, maybe I can use a vagrant. Vagrant is nothing but generally nowadays all people aware of the VMware virtual machines. So generally we configure the VMs manually, but instead of configuring the VM manually, Vagrant is a tool that automatically provision your VMs through scripting part. Maybe this QA guys may require some other softwares like in a Jenkins. Maybe this production may require a Ansible or Chef in order to deploy the application to the product. So obviously, all these three things, like in a development machine or Jenkins testing environment or maybe production environment, always must travels the must run the what a code, isn't it? That's very important. It should run the code. Now all this code must be properly configured. If you are not configuring properly, it's more problematic, right? Isn't it? So here configuration, when I talk about my configuration here. Configuration. That's if you're looking at my explanations in the previous statements, developers interacting, administration interacting, DB team interacting, server team is interacting. They have their own inputs. They have their own different tools. They have their own different configurations. And ultimately, when grouped together, some kind of inconsistency is getting. That's why what is alive before Docker is nothing but working on machine is the major problem because these many dependencies, these many configuration variances, these many changes, and obviously no uniform, no common platform. And one more thing is, as you know very well, how this configuration is going to be replaced and how this Docker changed the world of virtualization. So first of all, now I'm going to talk about the virtualization. But before virtualization, I hope you understand this exactly. So got my point, guys? And one more thing is be clear about this fundamentals because interviews may are Docker and Kubernetes is looking very hot and easy to tempt. But when people ask the questions, you may fail it. That's major problem. You need a lot of sense about to understand the topic. Okay. So in the real environment, the configurations, administrations, development and machine maintenance are managed and maintained by the various engineers. This is the major problem, right? I don't want. I want to have one program. That program is going to resolve all your dependencies issues, all your problems. For example, if you take the same figure, I'm going to represent, suppose here if I say, the same if I say I have development environment, I have a dev environment, I have a QA environment, I have a production environment. So in the dev environment, what I'm trying to say, instead of in earlier diagram, different kinds of configurations you are maintaining. You should not maintain the different configurations. I need in a simple configuration. That configuration is nothing but, here I can simply say it's called as a Docker. Docker is the one common platform that manage your all your development needs to the development, as well as testing, as well as production. So this, whatever we are planning to ship your code, whatever the uh, code you are talking on top of the code, so we are distributing the code. That code is going to be configured with the different environments in the form of different configurations. So this, my Docker is running with a single ship. This is, it manages the entire configurations. So what's the problem? What's the advantage here is, you can maintain the uniform. So you can maintain the same code, can be run on the development machine, can work on the test machine, can work on the production one. Whatever you're talking about application dependencies, again, I'm repeating, guys. Again, I'm repeating application dependencies. Docker address some solutions, right? This is the problem. So every time downloading, configuring, and setting environment variables, downloading the databases, connections, and verifying the code, it's very problematic. But when Docker comes to the picture, it combines all application dependencies into one single box as a Docker container or anything. Later we'll discuss. That can be executed on anywhere without reconfigure from the scratch. I don't require again administrator. I don't require any configuration manager. I don't require any other things like developer. Right? Keep my code. I keep my configuration. I keep my libraries. I keep my everything. I can able to wrap as a wrapper. That wrapper is going to run on the different environments without hesitating the basics, like working on machine is completely avoiding nowadays. Wherever it is, your application should run smoothly. That's why Docker is the area where you can develop, build, run, ship your application on anywhere in any environment across your network. So during this, in earlier development, if you're looking at you're looking at this kind of traditional development, there we use the concept called as a virtualization. So virtualization. So now I need to talk about the first virtualization. Have you heard about virtualization? Virtualization. So you need to understand the virtualization concept. Once you understand the virtualization concept, then I can able to explain what are the problems in the virtualization, then how the container technology will enter into the picture. Even one of the common interview question is, what is the differences between virtualization and containerization. Got my point? So hope all of you know about the virtualization. Nowadays, we are using VMs in our laptops, and we are using Oracle Virtual Box in our machines. Even if you go to our office, we are talking about the, yeah, I have a VM machines. I'm going to sit on my machine. I'm running that. So what is meant by traditional virtualization? What it says that, guys? Virtualization. And in a single laptop, you can install a, right, no, I don't have okay, no issue. We will install a virtual box or VMware. On top of the virtual box, you can run the multiple operating systems, isn't it? That is one of the main advantages. And each and every, suppose if I want to run dual operating system or triple operating systems, you can install the VMs, and on top of the VMs, we can install CentOS, Windows Server, and Red Hat, or maybe Mac and other operating systems. At a time, in isolated, we can run the multiple operating systems at a time. That is the main advantage of virtualization, generally, just for understanding purpose. And what is mean here actually? Generally, this virtualization represents the hardware level virtualization. Remember it. Hardware level virtualization. Hardware level virtualization. So, hardware level virtualization, in the sense, basically in this virtualization, it will take a complete operating system is going to running on your top of your host operating system. Host, host operating system. Getting my point? Host operating system, host OS. So host in this is my laptop. On laptop, it means when you're looking at the diagram. So here, even just best example, I already download some. See here. In the virtualization, if you take our infrastructure, we'll discuss. There is a hypervisor. I will discuss now. This hypervisor is the one of the internal component in the VM. We'll take care about it. On top of the VM with the via hypervisor, I can install guest OS 1, guest OS 2, guest OS 3, right? And what's going on here is, in this virtualization, a complete operating system will run on the hardware. It means when you take about this hypervisor is a special component in the virtualization technology. And there are two types of hypervisor. Keep in mind, type 1 and type 2. Type 1 and type 2. What is it, type 1 and type 2? So generally, this type 1 hypervisor, okay, provide the server virtualization, or you can, server virtualization. Generally, as you know, there are two types of operating systems I will discuss. One is a client-side operating systems and server-side operating systems. The same way, if you want to provide the virtualization to the server side as well as a client side, we need a hypervisor. So type 1 hypervisor will provide the virtualization of the server side, okay, on your complete hardware. And one more thing is, if you are in the type 1, there is not general traditional operating system. They won't install to you, right? Okay. But if you take that type 2 hypervisor, just like a normal desktop operating system, just like desktop operating system. And this is called as a server operating system. So it means hypervisor is a kind of virtual engine. Simple example, and again, if you want to say in a more deeper, virtualization engine. This virtualization engine is going to sit on your top of your operating system, and this hypervisor will securely manage your operating system in an isolated way, right? Every operating system has its own way of working. so that you can securely maintain multiple guest operating system. This is one of the main advantages. That's why if anybody has this question, what is the biggest advantages of your virtualization is? Obviously, I can say I can run many virtual machines with the different operating system. Am I right? I can run multiple virtual machines with different operating system on a single host. అర్థమవుతుందండి? Get my point? But what is the problems? That's why we need to talk about the problem in the VMs. That's why we need to go for the containers concept. That's called Docker. So first of all, before talking about the disadvantages, advantage is, secure and excellent, secure and isolated. That's most important. All virtual machines are completely isolated, and that's because of isolation is happen and more secure, right? Okay, but what are the problems here? You need to understand. You need to understand the problems more important. That's why here interviewer will stresses are who are working as administration side or who wants to improve your skills in the Docker. There are problems in the VMs. What are the problems in the VMs? Very common sense. Very common sense is here in the VMs. When you talk about the VM1 or VM2 or VM3 or multi VMs, always remember it. The operating system running via VMs, that VM takes the complete operating system. Let's remember it. So it takes the complete operating system from the hardware. What is meant by complete operating system? It means when you run a guest OS on your VM, and you run a guest OS on your hardware via hypervisor, it will take the complete operating system. Complete operating system in the sense, that's why I hate this kind of terminology. Complete operating system in the sense you should say like a device drivers. Device drivers. It will take device drivers as well as we have some kind of core system libraries. Okay. So it will take every resources of the operating system. It means the people say the VM is more resource hungry, generally technically called as a resource hungry, right? Resource hungry in the sense when you start the VMs, this is not that much easy to set up. That's another problem is it's not so easy to set up. Not so easy to set up, and it's one of the another this is one problem actually. Why? Tell me now. So, and a lot of people say in virtualized machine it is a hardware level of virtualization and it take a lot of time to spin off my machine. That's why I go for a container. No. That's not a more technical answer, right? Because you should say, what's the problem when you run multiple guest operating system on the single hypervisor with on top of the hardware machine? If you are in the single host, then you say the virtualization takes the complete snapshot of the operating system. When you take the complete snapshot of the operating system, it contains some core system libraries and as well as some kind of drivers will be required to share to each and every guest OS. And then the virtual machines require full installation. So I hope who come from the this one, the administration background, they can understand my voice, right? Requires a complete full virtualization. So full installation. And then because of this complete installation, more computing resources will be considered. More computing resource in the sense, can you please explain me? Yes, definitely. Suppose on top of my guest operating system, if I want to run my application one, or if you want to run another application on another guest OS, what happens, first of all, your hypervisor must be import. This is hypervisor must import. Once hypervisor is going to import, then your virtual machine will come on and it will power up. Once it is power up, then only you can start your running of your applications. And it will take a lot of time to spin up your machines, right? It will take a lot of time to run our applications. That's why keep in mind, guys, what are the problems in the VM and you should say this point, right? Okay. So virtual machines require the full installation. They require more resources to execute. And if you want to successfully run an application on any virtual machine, you should say first the hypervisor needs to be first import the virtual machine and then power up. And once it is power up, it will take a lot of time. Because of this nature, performance degradation is coming into the pictures. Remember this key point. If I have any hundreds of VMs, I have any 20 virtual machines ready-made, or on the demand based, I want even a message. Okay. So hope you understand, guys. That's why hardware cost, first of all, the hardware virtualization, and it will take the complete OS snapshot, and complete resources will be hungry, and more time taking to spin up your virtual machines. So if it is single virtual machine, I can do it. But if my application demand is growing, if n number of VMs are growing, if n number of VMs are hosting on the host machine, and if my hardware cost is increasing, how many number of times I can able to do it? So can you guess it? No, I can't guess it. And this is not that much, especially production. In Agile process, if you want to deploy to the application to the production, or if you want to create such kind of simulation, or if you want to create a kind of real environment, if you want to create it, that's not that much easy. Like that's why they want to apply, or they want to replace. I should not blindly say replace. Future sessions I'll tell you, because VMs are not gone to the history. Still, virtual machines are entered into the picture and it's already there. But I'm talking about the application environment, application deployment, and application shipping to move from one environment to another environment where some kind of inconsistencies happen. Obviously, VMs will take a lot of time. So within fraction of seconds and minutes, if you want to deploy, run, ship application across the networking without worrying about the same kind of traditional activities like a configuration part and setup part of your databases and OS setup, this is again hell. That's why the containers vanish those things, right? That's when the beginning of the sentence I already said, what about the preparing the software? And what about shipment of the software? What about the deployment of the software in a multi-heterogeneous complex infrastructure is involved? That's why you have to manage this kind of distribution, right? Where my software is running here, their other environment it's not working. So again, I need to download the new things. Again, I need to restart from the scratch. It's again bullshit. That's why they see in the top of the hypervisor, if you're looking at this one, on top of this, this is called container technologies, right? I will discuss what is meant by containers. So virtualization is in the virtualization environment, hypervisor is the major component. On behalf of the hypervisor, here there is a process level virtualization is entered into the picture. Remember, there are two types of virtualization. One is the I already discussed. This is called hardware level virtualization, and second one is process level virtualization. There is a lot of differences there. You have to dig these 2 points before move to the Docker. So process level virtualization is nothing but on top of your host machine, a kernel will involved here. No need to take the complete operating system by the different applications, right? In the operating system, kernel concept, internally process oriented concept will be involved. That process will speed up the creating the containers, creating environment easily, and it can easily deploy, ship, and run your application across the different environment. That's why what is the differences between hardware level virtualization and process level virtualization? In hardware level virtualization, on top of the single host, hypervisor giving a complete operating system to every software, every guest operating system. So what's the problem is heavy hardware consumption is going on, like a memory, networking, operating system, everything will be separate, isolated. Obviously, what happens? More memory room is required, more networking required, and more operating system is required in terms of libraries and configuration. But in the process level virtualization, also called the OS level virtualization, you can say. In OS level virtualization, what your Docker is doing inside the Docker is really working on the LXC center, Linux controllers, or maybe LXD, or in a simple terminology, I already discussed in the beginning of the Linux. Kernel. Kernel have a lot of inbuilt-in functionalities like user management, process management, device management, memory management, API concept, and networking management, inter-process communication. This is again a huge concept, right? So in the kernel, instead of giving the complete operating system as a whole snapshot, it will inject the LXCC concept. LXC, lateral discuss, don't confuse. Instead of giving the complete operating system, a process will involved here. So process management, that's why I discussed in the beginning of the Linux environment, process management. We exclusively discussed 2 hours call. What is meant by process states, process life cycle, what happens when the process is created, what is a bootstrap loader, what is a scheduler, what is a process queue, how to kill the process, and how to see the process. So every time a process is created, internally the process will manage the resources of the network as well as the memory as well as CPU, right? No need to unwantedly, unnecessarily giving the complete operating system to every application running on your. That's why internally it will differentiate. Internally, it will differentiate. That's why, because of this, you can easily create the process, isn't it? I can easily stop my process. I can easily kill my process. So that's why I can easily create a container. I can easily fill up my container with the multiple dependencies. So lateral disk. And internally, kernel will managing the entire hardware, entire configurations in terms of application need. Application need, and I said right, in if I am in the single computer, I have my CPU, I have my hardware, I have my networking, I have my device drivers, everything in my laptop, and it is not connected to the network. If it is connected to the network, again some networking concept, network device drivers, again I have to configure my hubs and routers, right? The same way, when your machines are growing in a container based, instead of configuring the complete operating systems, internally kernel will share all these required things to the application. What is sharing? Every container have their IP, every container have their own memory, every container have their own host information, every container have their own volumes. Of course, we'll discuss later. There are some problems in the Docker, like in terms of volume wise, in terms of auto scaling. We'll discuss later. The today topic is virtualization is problem. Virtualization is having a problems. We have to overcome this virtualization problem with the containerization. In containerization, we are implementing the process level virtualization. In the process level virtualization, whatever application is required, all the things will be shared under the process oriented via Linux controller only. So Linux controller is the heart of the Docker. We'll discuss definitely at the time of explaining what is a Docker container, how to configure the Docker containers, and how to deploy the application in the Docker container. What Docker really contains. There I can understand the actual meaning of the process level. Got my point as of now? Nara Elvera. Okay, good. So that's called as a. But now tell me, what is the basic idea about this Docker? The basic idea about the Docker is to pack your application dependencies into a single container. Right? So this is container engine. This container engine will carry the application run అవటానికి కావాల్సినటువంటి అన్ని డిపెండెన్సీస్ ని ఒక సింపుల్ కంటైనర్ లో పెట్టేసేసి ఆ కంటైనర్ లైనక్స్ లో ఉన్నటువంటి ఒక ఫ్యూచర్ కెర్నల్ లో ఒక ప్రాసెస్ మేనేజ్మెంట్ అనేటువంటి ఒక మెయిన్ టాపిక్ ని యూజ్ చేసుకుంటూ మనకు కావాల్సినప్పుడు హండ్రెడ్స్ టు థౌజండ్స్ అండ్ లాక్స్ ఆఫ్ కంటైనర్స్ ని ఇన్స్టెంట్ గా క్రియేట్ చేసేసుకొని మనం ఏదైతే ఐసోలేటెడ్ ఎన్వైరన్మెంట్ లో వర్క్ చేస్తున్నప్పుడు డిఫరెంట్ కైండ్స్ ఆఫ్ కాన్ఫిగరేషన్ ఇష్యూస్ మనం ఫేస్ చేస్తున్నామో వీటన్నిటిని అడ్రస్ చేస్తూ మీరు ఏ ఎన్వైరన్మెంట్ అయినా సరే నాకు సంబంధం లేదు, జస్ట్ నేను ఒక కంటైనర్ ఇస్తాను, అక్కడ మీరు సింపుల్ గా డెవలప్ చేసుకోండి, రన్ చేసుకోండి, మళ్ళీ దాన్ని షిఫ్ట్ చేసుకొని ఎక్కడికైనా సరే మూవ్ చేయండి. ఈ ప్రాసెస్ లో ఈ రిసోర్స్ కన్జంప్షన్, అక్కడ అప్లికేషన్ పనిచేస్తుంది, ఇక్కడ పని చేయట్లేదు, నాకు లైబ్రరీస్ మిస్ అవుతున్నాయి, నాకు కోడ్ ప్రాబ్లం ఉంది, సరిగా పోర్ట్ పని చేయట్లేదు, నెట్వర్కింగ్ పని చేయట్లేదు, డేటాబేస్ వర్క్ అవటం లేదు, ఓల్డ్ వర్షన్స్ ఉన్నాయి, న్యూ వర్షన్ కంపాటబిలిటీ లేదు, మళ్ళీ డౌన్లోడ్ చేసుకోవాలి, మళ్ళీ ఇన్స్టాల్ చేసేసుకోవాలి, ఇదంతా స్టాప్ ఇట్, ఇట్స్ బుల్షిట్. కాబట్టి బేసిక్ ఐడియా బిహైండ్ ద డాకర్ ఈస్ టు ప్యాక్ your application dependencies. Always remember, you should speak technically, right? So that contains the binaries, libraries, configuration files, and scripts, right? Into a single unit called as a container. Container is nothing but we'll discuss is an object. Even when you're looking at the ships, we have lots of containers are there. Inside the containers, some goods are there, some items are there. Item in the sense your code, databases, so libraries, scripts, so configuration files, blah, 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 blah. To speak technically, we'll talk. Container is working on the Linux file system. That's more important. That file system really contains the code. File system contains the runtime environment. That file system contains the tools. The file system contains the memory. The file system contains the networking. And me application development నుంచి production work move చేస్తే ఏ కైండ్ ఆఫ్ ఎన్విరాన్మెంట్ కావాలో ఐటీలో ఆ కాన్ఫిగరేషన్ మొత్తాన్ని లైనక్స్ ఫైల్ సిస్టమ్ గా డిఫరెంట్ లేయర్స్ లో కంటైనర్స్ లో ఇంజెక్ట్ చేసేసి ఒక ర్యాపర్ క్రియేట్ చేసేసి వదిలేసేసారు. దట్స్ కాల్డ్ గ్రేటెస్ట్. దట్స్ వై మీరు డాకర్ హోమ్ సైట్ ఓపెన్ చేస్తే అండ్ యూ ఓపెన్ ది డాకర్ హోమ్ సైట్, one second, Docker logo. So yeah, This is an official Docker logo, right? So this is called as a container, right? This is called as an engine. We'll discuss later. This is called ship. On top of the ship, it will you can create a container. You can move this container to one environment to another environment, right? Simply push there, dump there, run there, again keep it, again move there. So that's a very beautiful concept, very easy concept. Even a non-IT programmer also can able to manage the Docker. That's a very simplified thing. But if you want to move to this expert level, that's not that much easy, right? Because you should be very strong on the Linux environment. And one more thing is Docker. If you learn the Docker, then only you can go for the Kubernetes. Linux, Kubernetes, and the Docker and Ansible really utilizing the power of the Linux. That's why, of course, we can install the Windows, we can install the Docker on the Windows too, can install the Kubernetes on the Windows too. But in real time, even a faculty must only say must explain on the Linux only, right? Because internally the Docker is utilizing a concept called as a process level virtualization. ఇప్పుడు నేను చెప్పను, when you are in the containers concept, will have in a LXC. Even if you have in a JD, sometimes if you're looking at the JD, they'll ask this question. Candidate should have a knowledge on the LXC, and LXD. These are the container technologies, right? Fine. Now I got an idea about what is the process level virtualization, what is the hardware level virtualization. Okay. Now, what is a Docker then? What is a Docker? So, what Docker? How our Docker helps to the DevOps team? Why should I learn the Docker as a DevOps engineer? Because I said, preparing the software, shipment of the software, and deployment. Obviously, CI/CD pipeline. Right now, in the web application, we deploy the application as an var. Var contains only a code. Am I right? It doesn't have any operating system, isn't it? Var file contains only archives, web archives, contains the .class files only. But if I have a code, can I run the entire application? No. You need an operating system, you need any databases, you need other things. That's why, again, I'm stressing till end of my Docker concept. The basic idea behind the Docker is to wrap all application dependencies into a single unit called as a container. That wrapper is nothing but code, libraries, configurations, operating systems, databases, other files. You keep it. That's why when you want to do some kind of deployment, so that's why nowadays microservice deployment is hot in the market, isn't it? Microservices deployment. So not only microservices, even at the time of traditional web application development, you can convert that var to image also. You can deploy the images to the respective. That's why, as of now, we see only var deployment, but we don't know how to convert that var as an image, and I can store into my public repository as a Docker hub, like in a GitHub, how you push your source code to the public platform. Image and olden days సాఫ్ట్వేర్ ఫైల్ ఇన్స్టాల్ చేసుకొని దాన్ని నెక్స్ట్ అని కొట్టేసేసి ఇన్వాల్వ్మెంట్ వేరియబుల్ సెట్ చేసుకొని ఆపరేటింగ్ సిస్టమ్ వచ్చేంత వెయిట్ చేసుకొని అదంతా ఒకప్పుడే. ఇప్పుడు అది అంత సీన్ లేదు. ఇప్పుడు ఓఎస్ వి నెవర్ ఇన్స్టాల్ ఇట్, డేటాబేస్ వి నెవర్ ఇన్స్టాల్, ఎవ్రీథింగ్ దే ప్యాక్డ్ యాజ్ అన్ ఇమేజ్. జస్ట్ డౌన్లోడ్ ది ఇమేజ్ and run the image as a container. On top of the image, you join as an entity, develop your code, keep the code and save the code and push it and commit it. Again, create one image and push somewhere. Then you can travel. You can push the image to the next world so that you can run that application across your network. That's why, as a DevOps engineer, I want to know what is the containerization development. How can I take the containers under deployment? How can I inject my container deployment in the CI/CD pipeline? That's why even in the Groovy pipeline, you should know how can I convert this var to my image? How can I run my image as a container? Then how can I push this container to the Docker Hub so that at any given moment I can able to download the latest images. I can deploy into the respective configuration environment using Ansible. Then I can push to my Kubernetes in order to manage my clusters. That's why in CI/CD pipeline, Docker is especially used for deploying an application via containers. So that's why here I can use Docker as a Docker for deployment. But I said very clearly, developer can use it, and tester can use it, and ops can use it. Everybody they can use according to their requirement. Now, when you speak more basic terms in the beginner level, what is a Docker? A Docker is a tool, I can say, very common sense. Everybody know it. Okay. Docker is an API. Docker is an API, application programming interface. And Docker is an open source. It's an open source orchestration. Not orchestration, is an open source container management, container technology. Okay. And Docker is a platform. It's a beautiful thing. It's a platform. Is a platform. And one more thing is, I'll definitely explain the differences. మనం virtualization drawbacks discuss చేసాం. Virtualization is working on the hardware level. Container is working on the OS level. And because of this process, like hypervisor need to be imported, then it imports the virtual machine and power it. The whole process will take a lot of time. But in containerized technology, takes less time. Booting process is more in the virtualization. Booting process is less in the container technology. And it will take the complete operating system and more isolated. It is not more isolated. And when you compare with the VMs, containers are less secure. And VMs more on configuration environment. Not too much application, but of course, application is a part. But container is basically configured for the application environment, development, and deployment purpose. Okay, and it's a heavyweight process. It is a lightweight process. It's in hardware level consumption. It is a OS level virtualization consumption. Like you need to understand this kind of points. And of course, in future session, I will discuss very deeply. It's a Docker is a platform. That's it. Okay. Next is a platform independent. Is a platform independent. You can run on any operating system. But internally, the LXC, Linux control on LXC. And another thing is Docker. When you take with Docker, I said used to develop, run, ship application on in anywhere or on anywhere. Right? You can travel, you can move it. And more on, Docker comes with the 2 editions: community edition, enterprise editions. Community editions and enterprise editions. And the official website is here, see. Docker. So docker.com See, this is docs.docker.com is the official website documentation. So this is the get Docker. Go to the home. See here. So get started, download and install. You can see the guides. So they're given different kinds of announcements here. And if you want to see the Docker documentation, this is here. So you can go with the Docker file references, even Docker view, and if you want to see the Docker docs. And more on heavy commands only, even if you go with the Docker file reference. These are all we'll discuss later, don't confuse. I'm just talking about the references. You just go. So this is even lots of. So what can I use Docker architecture? We'll discuss how to work on and what are the different components. Even if you want to see the Docker commands. See ya. So you have lots of all these commands you have to by heart, and we'll discuss attach Docker image level commands, Docker container level commands, Docker volumes, and Docker networking, Docker Swarm, Docker Compose. We have different kinds of commands we need to discuss. So basically, without Linux environment, we cannot. Okay, that's first thing is. And the whole story of the Docker is, if you want to work with the software in the Docker, if you want to work with the software in the Docker, the all softwares in the Docker is available as an image. Don't confuse, we'll discuss Docker architecture. These images, best example, we pull the source code from the repository. If it is a public repository, anybody can access it. If it is a private repository, nobody can access it. Like officially, all vendors in the market, they develop their own applications, all their softwares like in a Windows Server operating system or Linux operating system or Tomcat or IIS, Java, whatever, even .NET. Nowadays, all softwares are turned into the images. All the images are stored into the public platform. We'll discuss, there is a public registry, public repository. So that's why here there is a Docker hub actually. So in the Docker, all your softwares you can download as an image. You can run that image as a snapshot as in a container. You need to run your software on the container. Then you need to deploy application via container. If there is no container, you can't. So container is nothing but runtime entity. Just like a image is something like an original certificate, and container is a Xerox. Normally, we never remove the images. We never remove the image in the sense we never disturb the base image. We'll discuss what is a base image, what is a layer. But always remember one key point as a DevOps engineer, or if a developer, or if a tester, the whole concept is image and the container zone. You need to know how can I run my operating system as a container? How can I run my web application as a container? How can I install my Java as a container in the container? So how can I start my container? How can I stop my container? How can I restart it? How can I interly connect to the networks via containers? How can I connect the containers in the network? How can I deploy my application in the container? So how can I move this application across the containers? So this is the thing you need to know in the Docker concept. So that's why slowly understand Docker changed the world of development, shipping, and running application across the globe. We are hassle free with the traditional development and testing and deployment procedures. Nowadays, every application information will be packed as one wrapper. We don't want to run with the different layers for different times in order to download it. Everything you keep it. You download it, you run it, again you can ship it. So development is faster, shipment is faster, deployment is faster. Especially imagine in a day or in a week, if you have hundreds of deployments are planned in large scale organization, shipping the application, while shipping application, any code is missed, any database missed, anything was wrong, goes wrong, going back and reviewing is very dangerous job. That's why I don't mind whether you're working in the dev or production, same environment, same thing, right? Don't say it's isolated, right? So that's why I can easily control it. I can easily monitor it. I can easily maintain my time. I can maintain a prototype. It's a best prototype to every environment in the project environment, so that I can save my time. I can reduce my time in the deployment part. That's why now the slogan is, how can I do deployment in the Docker? That's more important. Because as a DevOps engineer, you should inject the Docker. You need to develop the Groovy code and you need to create the container. You deploy the container. You have to save it, how it goes. That's what during these things, you should understand. Suppose if you go with the Docker Hub, here this is a place where you can see the all images. Just like GitHub Logger, Docker Hub. So you need to create an account. See, there is a sign in. Much better. Let us go and sign up. No, Docker ID is, say, suppose. Oh, caps panjeda. My container. My containers. చెప్పండి అబ్బా crosswalks. చెప్పండి ఇప్పుడు. Please also check the new images. So the inside మనకి ఇది అంతా ట్రాక్టర్స్ లో అంటే ఒక సీలో వెళ్ళాలి. సీ ఆల్ ఇమేజెస్ విత్ ట్రాక్టర్స్. ఇదా 1 2 బాగుంది. ఇది ఎందుకు అడుగుతాడు అంటే వాడికి తెలియదు. ఏంటిది తీసుకోవట్లా. Do you have anybody have Docker Hub credentials?
I have it. I have it.
Second. అలాగే మనకు కావాల్సిందే కదా. Let me create.
Can I send my credentials?
ఒకసారి ఇస్తే ఇంకోసారి తీసుకోడు. ఈ సైన్ అప్ అవ్వట్లేదు. That's okay. Now it's going on. See guys, when there is an obviously like in a GitHub we have a same plan, free for individuals. We have one private repositories and community supports, unlimited public repository. We have a pro for individuals, unlimited public repositories, 2 parallel builds and email, and the team for organizations, right? Unlimited public repository, unlimited private repositories, user management with role-based access, unlimited teams. So obviously this is the important for the real time, and $5 per month and $7 user per month. Starts with $25 per users, 5 users, right? Obviously, I plan very clearly. Maybe I'm going to targeting to my industry audience. So industry audience there, I want to purely explain the heavy concepts with the Docker and Kubernetes. For that, I'm going to take this part because more in real time, how can I create the private repositories? And how can I secure my private repositories? How can I configure my multi-host deployment? There, in a normal free, I may face some obstacles, right? I may have some hassles. That's why. But you, as a guys, as a beginner, no need to go with a pro and a team. Actually, simply continue with the free versions. Please check your inbox. Okay, go and remove the cam. So, just me wait. By passwords మర్చిపోతున్నానండి. So there is a tracker. Your payment అడిగారండి. They are not at received payments. Okay, guys, I need to pay. Okay, fine. So please confirm your email address, verify email address. So even everybody should create one Docker Hub. So account at the Docker Hub. So Docker Hub is the place where you can host your private repositories and public repositories. And we'll discuss what is a registry, what is a repository, what is image, and what is a container, and what is a Docker client and Docker daemon, Docker service, and Docker server. So thank you for attending. This is a CSE container is my what is that? My ID. Always remember it. And even you have a lot of things. Even if you're looking at the repositories, suppose you can search by repository if you create there. And suppose if you go and see, suppose I'm saying like in a Java. See, these are all images. There are different softwares will be available as images. And one more thing, the best image always looking at the number of downloads. Always remember it. The best one is even of course we can inspect the image whether it is valid or not because we cannot download blindly in the real-time environment. That's where Docker security is more important. But for beginner, how can you say, sir, which is the best image? Which one is the protected and best one? You can say based on the numbering. Right? So even if you go, suppose if you want to work with the Java, if you want to download this image from this Docker hub, you have to use a command called Docker pull an image name. So most of the times you need to use commands. Heavy commands are there. Even will get almost 100 and 100 nearly. Even will get more also. And the first and foremost thing is before installing the Docker in your local machine or virtual machine or in the cloud, first create a Docker Hub account. Just go and just log out. So again, just go and sign in. So Docker ID. What is Docker ID? CI/CD container. That's it. Adi guys, today and today we discussed about the virtualization. What is virtualization? What is hypervisor? Types of hypervisor, and what is the functionality of hypervisor? How the virtual machine will work? What are the problem in the virtual machines? And what is hardware level virtualization? What is a OS level virtualization? Differences between what is the life before Docker, how this Docker changes the life of developer and DevOps engineers, and what is the importance of knowing the Docker concept in the current trends, and what kind of deployment we are doing, and what is the Docker Hub, and basically we will talk about the Docker architecture tomorrow and Docker configuration, installation and configuration. And then we'll talk about the Docker images, Docker containers, then Docker files and Docker machines, Docker compose, okay, Docker, what do you call as a Docker service as a, of course, Docker compose only, and Docker swarm and Docker networking and bits Docker monitoring and Docker security, then CI/CD deployment using Docker, So like we have an even Docker Swarm, Docker Compose. So these are all కొట్టేదా ఉంది Docker Swarm, Docker Compose. ఇవి మనం బేసిక్గా నేర్చుకోవాల్సింది డాకర్లో. సో టుమారో మనం ఈ రెండు ఫినిష్ చేసి విల్ స్టార్ట్స్ ద డాకర్ ఇమేజ్ కమాండ్స్ అండ్ కంటైనర్ కమాండ్స్. ఈవెన్ Yeah, Docker volume management. Docker volume management. And we'll configure Docker with the ECS also, Elastic Container Service, as well as ECR in the cloud, how to do cloud deployments, okay? Because we're taking the cloud maximum. And what else? These are all things we are going to talk. Clear, guys? Any question? Okay, then. See you tomorrow about the డాకర్. ఇక్కడ మనం డాకర్ ఫైల్ ద్వారా మనం డాకర్ ఇమేజెస్ని ఎలా బిల్డ్ చేయాలి, తర్వాత డాకర్ పుష్ హబ్కి ఎలా పుష్ చేయాలి, మళ్ళీ డాకర్ హబ్ నుంచి మళ్ళీ ఎలా డౌన్లోడ్ చేసుకోవాలి, ఇవి క్వైట్ కామన్ మనకి. అవన్నీ ఇంకా ప్రాసెస్లో వస్తాయి. ఈవెన్ ఐ ఇంట్రడ్యూస్ ఎల్ఎక్సి కాన్సెప్ట్ మోర్ ఇంపార్టెంట్. సో ఇందులో కమాండ్స్ వస్తే స్క్రిప్టింగ్ పార్ట్, కంటైనర్స్ వచ్చినప్పుడు, డాకర్ ఫైల్స్ వచ్చినప్పుడు ఆల్మోస్ట్ వీ నీడ్ టు టాక్ అబౌట్ 13 కమాండ్స్ ఆర్ దే. 13 instructions ఉంటాయి. ఆ 13 instructions ఇచ్చేసి you should know how to build the image. From the image, how to run the image, then how to deploy the container. So here again, you should know how to integrate the GitHub with the Docker Hub via manual or webhooks in order to trigger it, and as well as Docker with the Jenkins integration. Quite common. So there I can save your time with the Nexus with the Docker Hub via scripting as well as a via manual. So మళ్ళీ ఇక్కడ డాకర్ జెన్కిన్స్ వచ్చినప్పుడు విల్ డిస్కస్ మోర్ మల్టీ కాన్ఫిగరేషన్ ఎన్వైరన్మెంట్ అండ్ మోర్ ప్లగిన్ and more heavy settings. By finishing this, by understanding the Docker swarm, we'll invite the KX. So ఇప్పుడు మీరు అనుకున్నట్లుగా ఇండస్ట్రీ వాస్ టాకింగ్ అబౌట్ డాకర్ అండ్ కుబర్నెట్స్. దీస్ టూల్స్ ఆర్ వెరీ హాట్ ఇన్ ద మార్కెట్. సో we need to give the more importance to the Docker and Kubernetes. Okay, that's it, guys, and catch you tomorrow at the same time, 7:30.